All right, so in assignment number 3, we are going to be simplifying radical expressions that involve quotients. That means we're going to be working with fractions and simplifying fractions. So let's go ahead and get started here. This is a review question. It goes back to what we were doing in assignment number 2, where we multiplied radicals together and then we simplified it. And so what I'm going to do here is multiply what I can multiply together. And I can multiply the stuff outside of the radicals together. So I can take 5 times 2, which gives me 10. And then I can multiply the stuff inside the radical together. So I'm going to take the 3x squared times the 8x to the 4th. And 3 times 8 is 24. And x squared times x to the 4th is x to the 6th. Remember, when we multiply like bases, we add the exponents. But then, there's a good chance that I can simplify this. Is there a perfect square that goes into 24? And so there is. I can take the 24 and write it as the square root of 4 times the square root of 6. The square root of 4 I know is 2. And so that means that if I have the square root of 4, I can just write it as 2. 10 times 2 I know is 20. And so I have a 20 on the outside. And then I have a radical with a 6 on the inside, because I can't simplify the square root of 6. But then I also have these 6 x's, and I want to pull them out in pairs. How many pairs would that make? And that would be 3. So my final answer here would be 20x to the 3rd times the square root of 6. Let's try number 2. Number 2 is a different idea. Here you can see there's no radicals. But we're moving to where we're going to have radicals within a fraction. And so let's just take a look at this fraction. We can simplify this fraction by looking to see what they have in common. Like what number goes into 12 that also goes into 18? And that would be 6. We can write 12 as 6 times 2. And we can write the 18 as 6 times 3. Which means those 6's are going to cancel out. And I have, the numbers at least, are going to be 2 over 3. But then I want to simplify x to the 5th over x to the 3rd. So a couple ways we can think about this. Remember, one way that we've done this in the past is we've had 5 x's on top and 3 x's on the bottom. And these 3 x's on the bottom can wipe out 3 x's on the top, and I've got 2 x's left over on the top. Or I can just simply subtract the exponents. 5 minus 3 is 2. So it's 2x squared divided by 3. And that would be how we would simplify this. So let's take a look at how we have radicals and fractions together. So this is sometimes confusing because sometimes it's hard to just do fractions. Sometimes it's hard to just do radicals, but when we put them together, sometimes that makes it difficult. But we can take a look at this, and there's a couple ways that we can do this. One way I can do this particular problem is I can just simply write this as the square root of 36 divided by 9. Well, we should know that if I take 36 divided by 9, that's 4. And then the square root of 4, well, that's 2. And so the answer here is going to be 2. But another way that I could do the same problem is I could take the square root of the top over the square root of the bottom. So I can take this radical and just divide it up into the square root of just the top and the square root of just the bottom. We know that the square root of 36 is 6. We know that the square root of 9 is 3, and 6 divided by 3 is 2. So regardless of which way I prefer to do it first, simplify the fraction first, as I did when I made it a 4, or simplify the radicals first and then simplify the fraction, we're going to get the same answer. Let's take a look and see how this applies to number 4. So if I simplify the fraction first, 90 divided by 5, well, that's 18. So the square root of 90 over 5 is the same thing as the square root of 18. Well, if I do the square root of 18, I can break that down into the square root of 9 times the square root of 2. And I did the square root of 9 because I know the square root of 9 is 3. So that's just going to be 3 times the square root of 2. Now I also could have done this by writing the square root of 9 over the square root of 5. But I don't know what the square root of 5 is, or the square root of 90 over the square root of 5, and I don't know what the square root of 5 is. I could probably break the square root of 90 down into some things, but looked like it was easier for me just to simplify the fraction first, and so that's the way I chose to do number 4. Let's go on and take a look at number 5 here. I could try to simplify this fraction first, and let's just suppose I did that. If there's some things that maybe go into 75 that also go into 48. And we can see that maybe one of the things that I can see that works is 48 is 3 times 16, and 75 is 3 times 25. And so these 3's can cancel each other out. And so 48 over 75 is the same thing as 16 over 25, which means the square root of 48 over 75 is the same thing as the square root of 16 over 25. Well, then I could just do the square root of 16 over the square root of 25. The square root of 16 we know is 4, and we know that the square root of 25 is 5. So this ends up being 4/5. Now I probably could have done that other ways. I could have done broken these up into the square root of 3 times the square root of 16, and that would have been 4 radical 3. I could have taken the square root of 75 and written it as the square root of 3 times the square root of 75, or square root of 25, but the square root of 25 is 5, and that would have been 5 radical 3. And then the radical 3's would cancel themselves out, and I would still end up with 4 over 5. So either way, number 5 simplifies to 4/5. Let's take a look at number 6 and see what happens when we not only have numbers within the radical or within the fraction, but we have variables. And so I'm going to do this one first by simplifying the fraction first. 27 over 3. Well, 27 divided by 3 is 9. And so I'm going to write this as 9, and then x to the third over x to the first, if I subtract those exponents, that's x squared. And so the square root of 27x to the third over 3x is the same thing as the square root of 9x squared. And what's the square root of 9? Well, that's 3. And the square root of x squared, that's just x. And so my answer is 3x for number 6. Let's move on here and take a look at number 7. What I like to do first is, if I can, is see if I can simplify just the fraction part of this. And I have 27 and 12. I want to see if there's a number that goes into both of them. And I think there is, because 27 can be written as 3 times 9. The 12 can be written as 3 times 4. And so if the 3's cancel themselves out, then I could write this as the square root of, instead of 27 over 12, I can write it as 9 over 4. Well, then I can do the same thing with the variables. This is x to the first on top, and I have an x to the third on the bottom. If I subtract those, I would get 1 minus 3, which is negative 2. And so if I have an x to a negative exponent, we know we want to make it a positive exponent, and it's going to go on the bottom as x squared. Another way that we can think about this is I will have 1x on the top and 3 x's on the bottom. Well, this 1x would cancel out one of the x's on the bottom, and I would have 2 x's left, and that's why we have an x squared on the bottom. So then I could just think about this as the square root of 9 on top and the square root of 4x squared on the bottom. And so the square root of 9 we know is 3, and the square root of 4x squared is 2x. Square root of 4 is 2, and the square root of x squared is just x. So my final answer is 3 over 2x. Got one more question here. Let's take a look at this and see if we can simplify this expression here. This time, if I try to simplify the fraction, there isn't anything that goes into 8 that also goes into 49. So I can't simplify the fraction. I'm simply going to have to write this as the square root of 8n to the fourth over the square root of 49. Now, there will be some things here that I can actually simplify. I know that the square root of 49 down here at the bottom is just 7. The square root of 8 can be simplified because there's a perfect square that goes into it, which is 4, and that's going to be 4 times 2. The square root of 4 I know is 2, and so I can write a 2 on the outside, and then what's left inside the radical is this 2 here. So I have a 2 on the outside and a radical 2 on the inside. Then I want to see if I can pull out any of these n's. There are 4 of them, and I'm taking them out in groups of 2. So how many groups of 2 would I have? And that would be 2 of them. And so my final answer is going to be 2n squared radical 2 all over 7. And that's what this problem would simplify to. That's what our homework assignment is going to look like for tonight. We'll work hard on that, hopefully do well on it. If not, we'll go over questions that we have tomorrow, and we will see you then.